Electric energy. Electric energy, the work done by a source of electricity to maintain a certain current in an electrical circuit is known as electric energy. It means for the maintaining the current in any circuit we need a energy. Consider an electric circuit through which current I flows for time t. Suppose in any wire current I is flowing for the time t, then the charge flow through the circuit for time t will be equal to Q is equal to I into T. Then the potential is developed in between this wire is what? Capital V. Now due to this potential and the charge, work has to be done by the charge to move from the position A to the position B. This work will be equal to Q into V. And as we know work energy theorem, this work is converted into the energy. So work done is equal to, we can say Q is equal to I into T. So I T into V. So the work done is equal to the electrical energy consumed in the circuit. So electric energy in the circuit is equal to V I into T, where remember V is the potential difference, I is the current, and T is the time taken for the charge flow in the wire. Similarly, we can also represent electric power. So electric power. In electric power, the amount of energy consumed in time t, then the electric power will be equal to energy upon time. And as we know, we have calculated energy is what? Vi into T. And when we put here P is equal to Vi into T, and the time T is cancel out, we'll get it, the power is equal to V into I. So the power of the electric circuit will be equal to V into I. The electric power is defined as the product of the potential difference applied across the circuit and the current flowing through it. We can also make other forms of the electric power. As we know the basic rules of the Ohm's law, V is equal to I into R. So when we apply these rules in the different forms, we can get the different results of the power. So P is equal to I into R into I. So power is equal to I square into R. This is the one result. Similarly, if I put I is equal to V upon R, I is equal to V upon R, we can get another result. P is equal to V into upon R. I in place of I will put V upon R. So we'll get it, power is equal to V square upon R. So these are the different types of different relations for the power: V into I square I, and V square upon R. Relation between electric power and electric energy, as we have calculated, this is electric energy is equal to power into time. So commercial unit also we must know, as we utilize in our domestic or commercially we say kilowatt hour. So let us say what is the commercial unit. So commercial unit of electric energy, and it is what? This is your kilowatt hour. So unit means what? Kilowatt hours. If we want to calculate this unit, we can calculate. First of all, we must know the concept of this one. When the 1 kilowatt power is consumed in 1 hour, we say the unit is 1 hour. Kilowatt hour is also known as broad of trade unit. So this kilowatt hour is also known as Board of Trade Unit. Board of Trade Unit. And in 1 kilowatt hour, 3.6 into 10 to the power 6 joule in 1 kilowatt hour is equal to 3.6 into 10 to the power 6 joule. Similarly, one more forms of electrical energy we can form, it is what? Electron volt. So one more energy we can take here is what? Electron volt. Electron volt is also the unit of energy. The energy of an electron when it is accelerated by a potential difference of 1 volt is known as 1 electron volt. What is the energy? The energy of an electron when it is accelerated by a potential difference of 1 volt, is known as 1 electron volt. Therefore 1 electron volt is equal to 1.6 into 10 to the power minus 19 joule. Okay, so the calculation of electric bill, how we calculate the electric bill, this is very easy calculations with the help of this electrical unit. We first calculate the total power in your house. So calculation of electricity bill. So energy is equal to power in watt into number of appliances, those are in the same wattage and used at the same time, and into the time in hours. So the power we calculate, suppose in our house the 4 tube lights are running for the 4 hours. So we'll calculate for 1 tube light and then multiply by the 4. So we'll get the power and electric energy consumed in domestic purpose. Suppose let us take one example for this calculation. Suppose an electric appliances of house consume 100 kilowatt hour energies in a month. So आपको unit are given 100 kilowatt hours in a month. Now cost of one unit is rupees 5. Then total cost will be 100 into 5 means 500 rupees. Okay. Similarly, one more example we can cover. Suppose one house has 4 bulb of 50 watt and it is blowing or illuminating for 2 hours. Similarly, fan 60 watt is revolving, it is illuminating for 6 hours. Then what will be the unit we have to calculate for the month? Unit for month will be what? So how we can calculate? First calculate the kilowatt hour, yeah, watt hour, then multiply by kilo. So watt hour of the bulb, so watt hour of the bulb is equal to what? 50 into 4, because the 4 bulbs are there and they are illuminating for 2 hours, so will be equal to 5 to the 100 and the 400 watt hours. Similarly watt hours of fan is equal to 60 into 1 fan is revolving, so 60 into 1 into 6 hours, 6 6 are 36, so 36 watt hours. Now the total electric power in watt hours will be equal to energy in watt hours will be 760 watt hours, and we need a kilowatt hour, so unit will be equal to 760 upon 1000, but it is only for one day. We need for the 30 days in a month, so we'll multiply by 30s also. So 0 and 1 0 is cancel out, this 0 is cancel out, we'll get it 3 6 are 18, 7 3 are 21 and 1 22, so 22.5 kilowatt hour, or we say unit. So this way we can calculate the unit for the month.